Hello dear students. Today let us study about ICBN, that is International Code of Botanical Nomenclature. So ICBN is the set of rules and recommendations dealing with the formal botanical names that are given to plants. It is the one correct botanical name which is accepted throughout the world. Who can change ICBN? The ICBN can only be changed by an International Botanical Congress, that is IBC, with the International Association for Plant Taxonomy providing the supporting infrastructure. ICBN is applied to plants, cyanobacteria, fungi, photosynthetic protists, and taxonomically related non-photosynthetic groups. Let us study briefly about the history of ICBN. It was Linnaeus in 1737 and 1757 who proposed the elementary rules of naming plants in his Philosophia Botanica. It was A.P. de Candolle in 1813 who set forth detailed set of rules regarding plant nomenclature in his Theorie Elementaire de la Botanica. The same rules of Linnaeus, A.P. de Candolle and his son Alfonso de Candolle were later evolved into our present International Code of Botanical Nomenclature. First International Botanical Congress was organized in 1867 in Paris, which was convened by Alfonso de Candolle. The International Code of Botanical Nomenclature 1983 was adopted by the 13th International Botanical Congress, Sydney, in August 8, 1981, and the chairman of the editorial committee was E.G. Voss. ICBN is divided into three parts: principle, rules, and recommendation. ICBN is now also called as ICN, International Code of Nomenclature of Algae, Fungi, and Plants. Let us study in detail the principles of ICBN. There are 6 principles of ICBN. First one states that botanical nomenclature is independent of zoological nomenclature. That means the code applies equally to names of taxonomic groups treated as plants, whether or not these groups were originally so treated. If an organism is considered to be a plant, then it must be named in accordance with the botanical code. If it is considered a bacterium, it must be named according to the bacteriological code. Next, moving on to the second principle, which states the application of names of taxonomic groups is determined by means of nomenclatural types. For vascular plants such as grasses, a nomenclatural type is a herbarium specimen that has been deposited in a herbarium. A nomenclatural type anchors the meaning of a name. If there is an argument as to what kind of plant the author of a name meant by a particular name, one examines the type specimen. No matter what taxonomic treatment is followed, the name must be used in a sense that it includes its type specimen. If, as occasionally happens, the author of a new name provides a description that does not match the type specimen, it is the type specimen, not the description, that determines what kind of plant is called by the name is the question. Adherence to the type principle did not become mandatory until 1958. Prior to that time, when taxonomists published a new name, they frequently simply listed several different specimens that exemplified what they meant by the name without identifying any particular specimen as the top dog among the example. All the designated specimens, including their duplicates, are referred to as SIN types, nomenclatural types of a single name, all of which were equally important. This became a problem if later taxonomists decided that there are two or more taxa among the specimens listed. When this happens, it became necessary to determine which of the specimens listed belongs with the original name. To prevent such situations arising, the rules for designating a type specimen were made more explicit. The problem was that if the collector made several duplicate specimens, each of the duplicate is a SIN type. There are several different kinds of type specimen, but the most important are holotypes, lectotypes, neotypes, and epitypes. The next most important are isotypes, SIN types, and paratypes. The first four kinds of type refer to specimens that are unequivocally the nomenclatural type of a name. A holotype is a specimen that has been designated the nomenclatural type of a name by a person creating the name. If the person who originally published a particular name did not designate a holotype, a later taxonomist may select a specimen to serve as the nomenclatural type. This specimen then becomes what is called as the lectotype of the name. If the holotype or lectotype is destroyed or lost, a new type specimen can be selected. Such replacement types are called neotypes. An epitype is a specimen selected to be the nomenclatural type of name for which there is a holotype, lectotype, or neotype available. Another specimen can be selected as the anchoring specimen. It is this specimen that is the epiphyte. Next, moving on to the third principle, which states that the nomenclature of a taxonomic group is based upon priority of publication. This principle states, in essence, that if a taxonomic group has been given two or more names, the correct name is the first name that meets the code standards for publication. Fourth principle states that each taxonomic group with a particular circumscription, position, and rank can bear only one correct name, the earliest that is in accordance with the rules except in specific cases. That means the uniqueness principle states that there is only one correct name for a particular taxonomic group within a given taxonomic treatment. It is the central principle upon which all the remainder of the code is based. If people disagree on the taxonomic treatment, they will consider different names to be correct. But within any treatment, each taxonomic group has only one correct name. Next, moving on to the fifth principle, which states scientific names of taxonomic groups are treated as Latin regardless of their derivation. So this states that scientific names are to treated as if they were Latin regardless of their derivation. Last principle states that the rules of nomenclature are retroactive unless expressly limited. That is, the retroactivity principle means that anyone proposing a change in the code needs to consider the effect that the proposed change will have no names published in a wide range of literature and over a considerable period of time. It is why all proposed changes to the code undergo committee scrutiny before being voted on. If the committee has a problem with a proposed change, one of its members will get in touch with the person proposing the change. The committee member may point out unforeseen consequences of the proposed change. Alternatively, he or she may suggest examples that will make a stronger case for the change or suggest modifications that will avoid some undesirable consequences. Next, moving on to the rules and recommendations of ICBN. According to ICBN, the detailed provisions of the code are divided into rules set out in articles and recommendations. As mentioned under the point number 4 of the preamble of 1983 ICBN, the object of the rules is to put the nomenclature of the past into order and to provide for that of the future names contrary to a rule cannot be maintained. The rules and recommendations of ICBN apply to all organisms treated as plants, including fungi but excluding bacteria, whether fossil or non-fossil. Nomenclature of bacteria is governed by separate code, which I already mentioned as International Code of Nomenclature of Bacteria, ICNB. So this is an introduction or the about the ICBN, its principles, rules and recommendations. Thank you.